Good morning to all. Now we are starting our concepts from the previous class. In the previous class, we discussed operations on signals with respect to time concept. There we discussed three important operations with respect to time domain. These three are time shifting, time scaling, and time reversal. In yesterday's class, we discussed time shifting concept on signals. Now we are going to begin with the second concept of time scaling on signals. Now, the concept is time scaling. The second concept is time scaling. This is the second concept. Now, what do you mean by time scaling? Time scaling operation has always been along the vertical axis. Now, just look at, we know that this is the time axis or the parallel axis. This is the vertical axis or depending axis. In the previous class, we discussed the time shifting operation. Time shifting operation has always been on only parallel axis, that is time axis. Now this time scaling operation should be always on vertical axis only. These two things students should remember. Again, just I am repeating. Time shifting is always on parallel axis. Always on parallel axis. Time scaling always on vertical axis. These two things just we have to remember. Now just look at. Let x of t be any signal. Let us assume that x of t be any signal. Now here time is what? Independent variable. Now x of at or alpha t, anything you can write. X of at is called time scaling. Just look at where a is a constant. Where a is a constant always greater than 0. Very important. Where a is a constant always greater than 0. That means what? Here a is a constant. We are multiplying a with the time domain t only. That means within the parenthesis concept only we are multiplying this a with the time concept t only. That means here two conditions allowed. Whether a is greater than 0 but less than 1 or a is greater than 1. Under these two conditions we discuss time scaling. Now just look at time scaling. This is time scaling. Two concepts. The first one is 0 and a is between 0 to 1. The second concept is a is greater than 1. In case a is less than 1, then the signal will be expanded. Signal will be expanded. This is called expanded. Expansion will be done on signal. Here if a is greater than 1, signal will be reduced. Reduction process will be done. This is reduction. That means reduced. These 2 points just we have to remember. Again, just look at, we are discussing time scaling. In the time scaling, two conditions are existing. This is the first condition. One more point, the constant with what we are multiplying the t variable, that should always be greater than 0. It cannot be 0. One more point, the first one is greater than 0 but less than 1. Second one is always greater than 1. In these two cases we are discussing time scaling. In case of this one, the signal will be expanded. In this case, the signal will be reduced, reduction process will go on. One more point. In both the cases, amplitude never changes. This is very important concept. Note, in both the cases, amplitude always the same. Amplitude remains constant. Amplitude remains constant. But what changes? Periods. That means foot periods are changing. Only foot period changes, but not amplitude. For example, look at this one. We are making one example. Look at this one. This is a graph given, t and x of t. Here there is a signal. For example, this is 0, 1, 2, 3, 4, 5, 6. Amplitude 1, 2. This amplitude is between 2 to 6. This is the actual signal given. What is its period? Its period expansion. X of t belongs to which one? What the period? 2 to 6. 2 to 6 only. 2 to 6. Now look at the footing. Starting point is 2. The last footing end point is 6. This we have to collect from this signal diagram. From this, for example, what is x of 2t? They may ask me like this. They will ask like this. X of t graph is given. Draw a signal of x of 2t based upon this one. Now just look at, you have to make a graph. Now just look at, this is the graph, t domain. This is x of 2t, we are writing x of 2t. We are writing x of 2t. Now just look at, this is t, time domain, t. What are the time intervals it is given? 1, 2, 3 up to 6. For example, 0. This is 1, 2, 3, 4, 5, 6. 6 it is given. Now here 1, 2, 3, 4, 5, 6. What is this one? In the previous case, t is a single one. Nothing is there multiplying, only 1 is the multiplier. Here 2 is given. Multiplier is 2. 2 is multiplier means, what is its condition? That means 2 is greater than 1. That means here we have to follow this condition. In this case, what happens? In the previous case, what is the given signal? Period. X of t belongs to which one? 2, 6. In this case, just now, x of 2t belongs to, divide this by 2, 2 by 2, 6 by 2. That means it belongs to 1, 3. So the new signal will be from 1, 3. There will be no change in the amplitude. Look at, the amplitude is 2. Never change amplitude. Here also amplitude never changes. But here, what is the period now? 1, 3. 1, 3. So this is the new signal of x of 2t. This is the new signal of x of 2t. Now just look at, this is the previous signal. What is width of the signal? Width of the signal is from 2 to 6. It was a big range, 2 to 6 only. Now because of a numerical value that is greater than 1 is multiplied with time domain variable t, the graph, signal graph will be reduced. Now just look at, here from 2 to 6, the width is 2 to 6. Now here the width is 1 to 3. 2 to 6 comes to 1 to 3. That means what happens? The signal size is reduced. It is because of the factor is 2. 2 is greater than 1. The first case, that is the first case. Again, just I am telling, look at, time scaling concept is always on vertical axis only. There will be no time scaling on parallel axis. But in the previous case, time shifting is always on parallel axis, time axis, but not on vertical axis. These are the two differences between these two axes. Now regarding time scaling, two concepts are arisen. Here time scaling means what? Scaling, we are scaling the vertical axis, either scaling or down, coming down. Going up or coming down of the signal. Now just look at with what factor are we multiplying? We are multiplying with A. That A can be in two conditions. The value of A can be either less than 1 but greater than 0. Second case, always greater than 0. In no case A is equal to 0. A is a constant, always greater than 0 only, greater than 0. Now here in this case, whatever the signal they give first, as in the previous case we discussed in the time shifting, first collect what is the width of the signal. This is the width of the signal from 2 to 6. Here amplitude is how much? 2. The new signal, the amplitude is also 2. There will be no change in the amplitude. There will be change only in the width of the signal. Here they asked what is x of 2t. 2t means 2 is a number, numeric number. That number is greater than 1. 2 is greater than 1. So greater than 1 means what? The signal will be reduced. With what quantity will it be reduced? Look at the width, 2 to 6. Now 2 to 6 means divided by 2. The factor is what? 2. Divide 2. Divided by 2 means what? 1, 3. So the new signal we have to draw from 1 to 3 only. But there is no change in the amplitude. These two things students have to understand very properly. This is a time scaling. This is the first condition we discussed. This is the condition we discussed. Similarly, for this one, concentrating on this one, what is, for example, T by 3 graph of the signal? What is x of T by 3 based upon this one? Now, based upon this one, here just look at T by 3. T by 3 means what? T, that is multiplied by 1 by 3. 1 by 3 is a constant. That 1 by 3 is what? This 1 by 3 is greater than 0 but less than 1. Greater than 0 but less than 1. Therefore, this condition we have to apply. Which condition? This condition. So here 1 by 3. In this case what happens? The signal will be expanded. Because of this condition. So here any signal you can make it 2t, 3t, 4t, 5t, 6t. In all the cases, the signals will be reduced. But t by 3, 2 by 2, 2 by 4, by in denominator, by 4, by 6, etc., etc. In all the cases, signals will be expanded. These two things just we have to discuss here. One case we discussed. Now, the next one, we are continuing with this one. Thank you.